This is 6.3 numerical model. The numerical model is a way of analysing an athlete's performance. It is used the application of mechanics of the human body and sporting performances, and looked at the force exerted by the body and calculates and explains results for those forces. This method of analysis includes looking at the physics behind the movement and looking at the data in a qualitative manner. This includes looking at the kinetics of movement, which are the causes of movement, and then turn it into quantitative data. For example, looking at the force produced in newtons. This also includes looking at kinematics, which is the description of motion, or the movement for the performer, such as the velocity, which is then also changed into quantitative data, such as meters per second. This method uses quantitative data and puts it into graphs so we can easily see the difference between the athletes. This model also looks at the different types of motion. These include linear motion, which is the movement of a person or object in a straight line, angular motion, which is the movement of a person or object, that is, for example, changing direction, and projectiles, which are angles of release and attack. These factors are also used in the numerical model. When creating a numerical model, we take previous scores from many different sources, including literature, elite athletes, and a combination of both. For literature, you need to check the credibility of the journal or article, as someone may have published a journal on the internet that gives out false information. Also, when using information found on the internet, you need to check the credibility, as someone could have made up the information just because they like the sport. Information can also be collected from elite performers. For example, in our basketball model, we will be collecting data scores for certain fitness tests from NBA players. You can also look at groups of data collected from people the same age as your participant. These are called normative data tables. This is where you can see whether the performer is above or below or on average compared to people around the same age. Lastly, you can do a combination approach and look for both. With this information and scores, you can then compare it with your performer. This may include producing graphs so that the difference can be observed. Linear motion is made up of 3 types of motion, including linear motion, angular motion, and general motion. Linear motion is the movement of a body or object in a straight line, meaning that it does not account for direction, as all parts of the system move the same distance, direction, and at the same speed. True linear motion is rarely found in sports, but an example of this would be a 100-meter sprint on a straight track. Next is angular motion, which is a system which moves around an imaginary or real axis in a circular path. All parts of the system move at the same angle and in the same direction at the same time. And an example of this would be a gymnast on the bars as they swing around the bars, which act as an axis. Lastly, in general motion, which is a combination of the 2 motions and is the most common in sport. Linear motion can also include curvilinear and rectilinear motion. Curvilinear motion is a movement along a curved line in one direction. An example of this could be on a long jump, as the performer jumps forward and comes back down whilst moving forwards, whereas a rectilinear motion is a movement along a straight line, such as jumping upwards or running. The numerical model also looks at a scalar and vector quantities. Vector quantities are described in terms of size and direction, such as weight, whereas scalar quantities are described in terms of only size, such as mass. Scalar quantities are values that have a magnitude, meaning how big, far, or fast they are. For example, mass describes the amount of matter a body possesses, whereas vector quantities have both direction and magnitude. For example, weight is your mass and the gravitational force that's applied to it. Some other examples of scalar quantities include distance, speed, mass, and inertia, and some other examples of vector quantities include displacement, velocity, acceleration, deceleration, and momentum. Distance and displacement are an example of scalar or vector quantities. Distance is a scalar quantity and is the sum of all movements regardless of direction as a value, whereas displacement is a vector quantity and is the difference between an object's final and initial position. So it takes into account the route as a value and the direction as a value. The direction can be shown in degrees. An example is shown in this picture. The distance between the start and finish could be roughly 10 kilometers, but the displacement will be greater, so it could be up to 20 kilometers, as it accounts for the direction that the runner took. Speed and velocity are other examples of scalar and vector quantities. Speed is a scalar quantity which is measured in meters per second and considers the distance at which a body has travelled. Speed is how quickly your body moves and the rate of motion. You can work out the speed by dividing the distance covered in meters by the time taken in seconds. For example, a sprinter runs 100 meters in 15 seconds, so their speed would be 100 meters divided by 15 seconds, which is 6.7 meters per second. You can also work out one of the other values of the equation. For example, if you have the speed and distance covered, then you can work out the time taken by rearranging the equation into a triangle, with distance at the top and speed and time taken side by side at the bottom. If you then cover the thing that you want to work out, in this case it would be the time taken, you would then have to work out what is left. So that would be distance divided by the speed to find the time. Velocity, however, is a vector quantity, which considers the displacement of the body and the time taken. Velocity is also measured in meters per second and can be worked out by dividing the displacement by the time taken. For example, a runner took 15 seconds to run 100 meters, meaning that their velocity would be 6.7 meters per second, and another runner ran 400 meters in 120 seconds, meaning their velocity would be 6.4 meters per second. The velocity calculation can also be made into a formula triangle. Similar to the speed equation, displacement is on the top, and so we wanted to work out displacement, we would cover that up and it would leave us with velocity and time. As velocity and time are at the bottom of the triangle, we would times these two together to get the displacement value. Speed and velocity can be plotted on graphs known as distance time graphs and velocity time graphs. Distance time graphs show you distance on the y-axis and time on the x-axis. You can see that on this graph here. On the image, the first part shows no motion. However, as the line starts to move upwards, it is showing acceleration. As the line begins to flatten and becomes diagonal, this is showing the person travelling at a constant speed, which is here between C and D, and then between D and E, you can see the curve begins to go back downwards, or the opposite direction to the start, showing deceleration. On this graph, you can find out that the speed at any point as the gradient of the curve is the distance divided by the time, which equals the speed. These graphs up here are velocity time graphs and show the amount of velocity. These graphs have velocity on the y-axis and time on the x-axis. The graph on the right shows that the body is moving with increased velocity, also known as acceleration, and the graph in the middle shows the body moving with decreased velocity, also known as deceleration. The last graph on the right is showing motion at the same velocity over the time of the motion, meaning that their movement is at a constant velocity, so there is no acceleration or deceleration. This graph is another velocity time graph, but has acceleration, deceleration, and constant speed all in the same graph. You can see here it is a gradual acceleration. Here it is quite a sharp, quick acceleration. This is constant speed, and then we can see a really rapid deceleration. Sorry, that was my sister. Acceleration is a measure of how quickly velocity changes over a set period of time. You can calculate the acceleration by dividing the change in velocity by the time taken. If the calculated figure is positive, then it is acceleration, whereas if the figure is negative, then it's deceleration. In this picture here, we can see a swimmer coming up to the wall for a tumble turn, and we can see that she is moving at a constant velocity. As she approaches the wall in the positive direction, she has zero acceleration as she's moving at a constant velocity. She then shows deceleration when her hand is making contact with the wall, because she's trying to decrease velocity in the positive direction, so that when she pushes off the wall, she can increase velocity, but in the negative direction. So she's going to be doing negative acceleration. She then increases her velocity in the negative direction as she's swimming off. Another example that we might see acceleration and deceleration in the positive and negative direction is in a game of basketball, as the athlete is constantly changing direction, and there is therefore accelerating and decelerating constantly. For example, the athlete may be accelerating towards a goal to follow a player, when the ball is taken possession by the other team, so you have to start running the other way. So the athlete shows deceleration, and as their foot pushes against the floor, they are then accelerating in the negative direction, so they are also performing negative acceleration.